Math 3 students, this is a video for section 2.5 on absolute value functions. So to begin with, let's review a very important definition, which is parent function. So in our last class we looked at different kinds of transformations of functions that created a family of functions. So a parent function is the simplest form of a set of functions that form a family. So for example, if we take the family of quadratic functions, then y equals x squared is the simplest quadratic function, so it's a parent function. Other quadratic functions in the family of quadratic functions using those different transformations, such as h, k, and a, we can get things like the following, such as y equals x minus 3 squared minus 1. So you can see we have an h of 3 and a k of negative 1. Or also we have y equals negative 4x squared. So we have an a of a negative 4. So those are just two ways that we can take the parent function and create different functions. So this section is specifically looking at the parent function, or the family of functions y equals absolute value of x, the absolute value functions. So the parent function is just that, y equals the absolute value of x. This is as simple as an absolute value function can look. So anytime you learn how to graph anything new, it's a good idea to really pay attention to the parent function and know how to graph it inside and out, and so we're going to do a simple t-table. So just to remind you, when you take the absolute value of a number, it's going to either make it positive if it's already negative, or keep it positive if it's already positive. So the absolute value of negative 3 would be positive 3. The absolute value of negative 2 would be positive 2. Absolute value of negative 1, positive 1. Now the absolute value of 0 isn't positive nor negative, so it just stays as 0. You may also remember absolute value means the distance a number is on the number line from 0. So 0 is a distance of 0 from 0. It's not any distance at all. It is itself. Alright, the absolute value of 1 would stay positive 1. And these would also stay 2 and 3. Okay, so now let's plot our points. So negative 3, 3 would be over here. Negative 2, 2. Negative 1, 1. 0, 0. So far it just looks like a line. And then 1, 1, we go back up again. And then 2, 2. And then 3, 3. Now if I were to put in more numbers like negative 4, negative 5, negative 6, I would see essentially a shape forming here that would keep going in this direction. And then we can do another shape or another line going in this direction. Okay, and so you get a V shape. So this is the basic absolute value function. So we're going to use those transformations to create new versions of the absolute value function. Okay, so these transformations that we're going to look at are the same transformations we looked at in 2.4 that apply to any function. We're just looking at them specifically in the case of an absolute value function. Okay, so we're always taking our parent function and we're changing it in some way. Okay, so the first change that we can make is a vertical translation, and that would be using k. If we add a k, it's going to make it go up. If we subtract k, so if k is negative, then it's going to go down. Alright, then we've got horizontal translations. So this is the h, and the h is the weird one where things are a little bit backwards. Okay. The way the book does it is they're trying to help you out, but I don't know if it's going to make it more confusing or not. But if you see a minus h, you're going to the right, because what that means is h is actually positive. Okay, and then when you see a plus and a number h, well, that means you're going left because h is actually negative. So just think opposite signs for h. All right, what's next? Well, then we have a. The a is we have vertical stretches and compressions, and that is going to be a stretch if a is greater than 1, and it's going to be a compression if a is a number between 0 and 1. Okay, but when we're talking about a, we're not talking about the negative. The negative will do the thing where it flips it upside down. So that's where we get a reflection. So if we put a negative on the outside, it's going to flip it over the x-axis. And if we put a negative in the inside where x is, that's going to flip it over the y-axis. Okay, so with all these transformations, which ones do you do first? So my suggestion is to always start with whatever a is. Okay, you can even try graphing y equals a times the absolute value of x using a t-table, and then you can then translate that, so move it up, down, left, and right using the h and the k. And also keep in mind that a negative a will flip it upside down. But you don't even need to remember that because the table will do that part for you. All right, so in part 2, we're going to look at some examples.